Hello, this video will cover chapter 3, that is about profit maximization. And more specifically, we'll be talking about allocation of one variable resource. It's how do you allocate one variable resource, and how you can use Excel to derive the functions and to find graphically what you can also find mathematically. So early on, we discussed the functions here, the production function and the cost function, and in those, so this is a production function, and I'll show you how to compute everything, given this example of function here. That's what we have, and how we derived everything. Just to go back here, the marginal is again the difference between output. Marginal is difference between total cost and output cost. So it's going to be equal to, so the second line, 1200 minus 100 and 3.7 minus 0, and you continue doing that all the way down. Okay, so in this video, we'll talk about one resource allocations, and we'll use both our production and cost function to compute or derive the optimum profit. So what do we need? So we have the same functions as we started with originally, which is x squared. Okay, the function is y equal a squared minus 1/30 x to the power 3. And so that's the function we'll be working with and deriving. So the first is a total. So here we start with the cost functions, right? And the information we have is that the fixed cost is 1,000. And so I probably put the fixed cost somewhere. No, but I use it anyway. So the total cost, okay, so what is function here, I'm going to show you. So it's going to be equal to, see, I'm using this here, total cost, okay? Total cost, so this total cost equals fixed cost plus total variable cost. Total fixed cost plus total variable cost. And so, so I1 that you see here, I1 is my total fixed cost. So I take my total fixed cost and I put $2 sign around the I, so that when I drag my function down, okay, it locks down this function I doesn't move. What will be moving are the input cost, and so F1 is the price, right? So total cost is total fixed cost plus total variable cost, which is equal to quantity of input used, okay, which is A, time the price. Again, I do the same thing. I lock down my price cell, so that when I drag my function down, only the A will be moving. I will always have the fixed cost, and I will always have the yes, and I will always have the price of X. That does not change, obviously. To get the total variable cost, you multiply the price of X by the quantity of X that you are using, which is A. So if I need to show you differently to get that result, okay, what I'll do equals, so I type equals, total fixed cost is 1,000, so I click on the cell I1, and then I press the function F4, okay? So F4 to lock in a cell. Okay. So I have that, and is my total fixed cost plus my total variable cost is the input price times the quantity used. So the input price is 100, is my cell here, is my cell F1. Again, I press F4 to lock it in, okay? And I'm going to multiply that F4 by the input prices. I click enter, and that's what gives me, okay, what gives me 1,200. Okay, where's my 1,200? 1,200. So the same thing, and so that's how you do. Now, when I lock all the cells, I can take this, and I'm going to. This is stuff is on my way. I'm going to come to the right lower corner to see that black cross. I'm going to drag down my information, and so that's what we're going to have. You see those two functions are the same. So by computing total costs, we already computed total variable cost, which is again G1. G1, so the price. So G1 is, where is B? Let me see. Total variable costs. It's supposed to be 12 PX. This is, oh no, it's not total variable cost, of course. Total value product. Okay. It's like, oh, it's a problem. So total value product, right? So we need the total value product, and because we're going to graph it here. And so the total value product, it's product. So it's going to be, if I get here, it's going to be again G1, the price of Y, times Y. And so basically total value product is basically total revenue. And so how much do I get if I sell everything? So my sales are equal to my production, Y, times my price. And that's how I got 1,200. And so profit, obviously, is the difference between total cost and total revenue, right? Because total value product is the same as total revenue. And you can see here, total value product, I just put this function here to call you total value product or total revenue are exactly the same thing. So again, as I just showed you a few minutes, the marginal is going to be equal to the difference between Y, okay? So that's the derivative, change in, so this marginal is going to be equal to change in Y divided by change in X, and is equal to the marginal physical product, okay? All right, and so the change is going to be change in Y, so it will be, I'll show you here, so it will be B4 minus B3. That's what we see there. Okay, let's move this out of the way. And so the value marginal product, okay, is not complicated. Is nothing but the marginal physical product time the price, input price, right? And so that is, there we go. Okay. So what we're trying to figure it out here, right? What is the optimum input that will be used, right, to maximize profit, So to find the optimum input that will be used to maximize profit mathematically, what we do, okay, so we know that profit equals, so total revenue, which is Py times Y, okay, that's value marginal product, minus total fixed cost minus total variable cost, right? So Y is also, we know that Y equals is a function of X, that's why it is, okay? And so we can replace this Y by our function of X. Don't necessarily have to, but let's give us a profit is equal to the price of Y time the derivative, so basically the marginal physical product, right? dy profit equals Py time dy over dx, okay, minus total variable cost, because the derivative, when you take the total fixed cost, is a number, so 0. So total variable cost, the derivative here is going to be, total variable cost is px times x, okay? So the derivative here is going to be px. So that's what we need to, this slope, we need to set it to 0 to derive the profit function. So if you use our same example, okay, our same function that I wrote down somewhere earlier, okay, so y, so we compute the derivative basically of y, okay, so y equal x squared minus 1 over 30 x to the power 3. So d of y over d of x is going to be 2x minus 3 divided by 30 times x squared, right? So we replace the values. So derivative of profit, oops. So g over g of x is going to be equals to 30, which is the price of y, time the marginal physical product, which is 2x minus, or basically 1 divided by 10, x squared, okay, and minus px. Oh, sorry, minus 100. And so basically it's going to be 30 okay, times 2x minus 110 x squared equals 100. And so now we need to take, to find out, we need to use our formula, okay, to find out x, and I've done that in the over product. So we found out actually that x is equal to 18.2, I believe. Well, we see here. So what is the optimum? So the optimum, so this is the slope, okay? So you can see that with, we are going to take the slope of the total cost, apply it to the total variable product, okay? Because again, revenue has to be equal to cost, so that slope has to be the same, and it will give us this point over here, okay? So if you come down, it will give us, so I think it's 18.2. will double check maybe somewhere. Right. Okay. Equals here is 18.2. So that is the optimum level output that will be produced, okay, given the total value products. And so on the profit function, right, this is profit, okay, is going to be the maximum point on the profit function, because we want to know what input level am I going to produce, okay, to maximize my profit. And that's what we derive here. That's 18.2, okay, is basically by deriving profit and find the optimum level that is here. Now, you can see that, everything is, nicely aligned for me. It may not be easy for you to figure it out, but I'm going to show you very quickly how I did to align everything. First, if I select the outer box, okay, I'm going to right click, and you see at the end, you'll see format chart area. And over here, you can do all kind of things, okay? The width of the curve, etc. But what I did is that I came to the size of the box and I line up the size, okay? Originally it was different, and you can keep or not keep aspect ratio, but if you remove the aspect ratio, that means that you can freely set up, the height and the width. So I set up to 3 and 5, and I did the same thing for each one of those three curves, okay? And so that's how they align nicely. And of course, you also have an inner box, right, that you can move, okay? Because you can format it too, but I just moved it, in my case here. No, so I just moved it, okay? So just move it so that those align. Oops. So that, well, no, I moved it maybe, so that the axis align, so I can see that it's the same thing. And if they're the same alignment, then obviously I can come down to figure this out. And so, of course, in the table, we can figure out where 18.2 is, okay? Yeah. So 18.2 is, well, obviously between 18 and 20. And so technically over here, we find out, no, total revenue, where's the Y? Right, okay. So technically we'll see that 18.2 is between those two values here, right? And so between those two values here, that's where we're going to see the profit reach a maximum and then decrease, obviously. So the profit is first negative because you only have a fixed cost. And if the fixed cost is higher than the revenue that you are making, so if your cost is higher than your revenue, then you are losing money. Then you start making some money until you get to the maximum, right? And then your profit decreases again. An important things to why did I do that? To notice is that on the total value product, okay, you can have a higher revenue and use higher input, okay, but you'll be making more money, less money, sorry. So the optimum input used to maximize profit is not the same as the optimum input to maximize revenue, right? And so very often, if you look at in FFA or farmers yield competition, they try to maximize yield, Okay, and the same that we found earlier, we try to maximize yield, but by trying to maximize yield or maximize revenue, sometimes they end up losing money. It's not the best way to go. You have to, to weight the input and variable cost over time. And one thing that we already talked about in the previous video, our outcome is that, the conditions to begin with is that value marginal product equal PX, right? And value marginal product, basically it's the change in revenue. Okay. Change in revenue. Sorry, revenue has to be equal to price over time. And so to get the optimum, right? And so here we also see that we have the same approximately, because this is not well done. If I adjust it to line up, okay, then I should have, so a little bit more. Okay, so I should have this first same 18.2 over here. Okay, and so the price, this is the price, PX equals of input is 100. And so the value marginal product is the output price times, let's see, it's the output price, so it's G1, okay, times, of course, value marginal product times marginal product, right? Okay. So when the value of your marginal product, and so that's what it is, okay, is change in revenue, additional revenue, okay, is the value of your marginal product, value marginal product, has to be equal to price. That means that if you produce one more unit of Y, okay, that unit has, what you get out of that unit, the value of that unit has to be at least equal to the input price. That means if you spend more on input to get less than the input price, you're losing money. If you spend, let's say, if you spend 30 on input and your revenue is 20, that means you're losing money. But if your revenue is 40, that means that you're making 10. Okay, and so the value marginal product increases. It reached a maximum. Okay, so basically that is the beginning of stage 2, right? Okay, so that's where we have. So it's here. These are inflection points. Our inflection point. So our inflection point is, basically is here. Is designates the maximum of the value marginal product or the marginal product at the highest level. And so we have increasing diminishing to scale, diminishing return and decreasing marginal return. Okay, decreasing marginal return. And that is okay, obviously. What you don't want is that the value, okay, of your productions becomes lower. So we don't want it to be here than the price of input that you are paying. So we do the same thing for, and again here, right? We are computing, and you are trying to find out as a function of x. We are trying to find out what is the optimum input is, and so we set up our equation, our profit function as a function of x. We can also figure it out, and from there we can find out y by replacing, in the different functions. We can also find out what is the maximum output, okay? And to look at the maximum output, we also need a profit. That does not change. Okay. But here, our x, so here, right here we have, so we have, okay, have our x here, and here we have y. sorry, profit, not X total value. Well, I mean, you know, value, but or dollars. Okay. And the X, so X in here, you have how much do we get? So your profit, what's the minimum input to use to get that profit? When you maximize output, you have something, you know, not the opposite, but close to. So our X, okay, here we have Y, and again we have dollar value here. Okay. Because what we are changing is the output. We want to find out what is that optimum output, right? And so we are varying output. What is the optimal output? So the output, right? So we want to find out the optimum output, and it seems like it's somewhere around, this is lower, around here, okay? So that is maximum profit, right? To maximize profit, okay, basically, how much do I need to produce? That's what it is, okay? How much do I need to produce to maximize profit? And beyond that point, I'm going to lose money. So many of the same equations, okay? And here are value marginal input, value marginal, let's see, costs, and value marginal profit. Okay, those two function there. I don't want to be, you know, way too long, but again, apply the same principles. You know how to compute total revenue, marginal physical product, and value marginal physical product. We have the same X here. Here we have a price because we want to see, you know, where the price stands, since the value marginal product should not be lower than the price. Okay. And on our graph here, we can see that profit is 0 here. That's the at 10, the inflection point. Well, yeah, at 10 for X, right? And 66 for output. But when we have our maximum profit is around this area here, right? So is 18.2 we input, so the corresponding that we need to find, the optimum that we need to find is somewhere something slightly above 129.6. Okay. At that level, okay, we pass that level, profit decreases. To the higher it decreases too. Okay. And so what we have to find out before we look at, okay, what is the optimum input? Now we need to find out what the optimum output. And so our cost again, you know, total revenue, no, marginal, because it's a slope. Okay. So marginal revenue equals marginal cost. That means the slope of a marginal cost and the slope of a marginal revenue are the same. Once we know the slope of a marginal, the slope of the variable cost, okay? So we take variable cost because fixed cost is fixed, so it doesn't affect anything. The derivative of a fixed cost is 0. So we are really interested in the variable cost. And that slopes equals the same slopes on the total cost. Let's see, that should be the same as the total cost. Sorry, it's not here because total cost has the same slope as variable cost. Okay, and so we can set the two to be the same. So what we're really looking for is the optimum profit. Okay, and we know that it's going to be around 120 something, 120 after 129, and so that's where we're going to have it. So the optimal profit will be here, and we are going to see that when the profit is optimum, I'm going to enlarge this one, okay, just so that we can see a little bit better. The line will be different, but at least you'll see. So we are also looking at what is the point, okay, at which the marginal cost becomes higher than basically the price. Okay, so if your price, so you know your price is fixed. Oops, I have an issue there. Small technical issue. It's done. So I'm going to finish here because it's been a while, right? So you want that price, the marginal cost not to be, as long as the marginal cost is below the price, you're making money, but if it's above, then you're losing money. So this is your marginal cost. So that's what I have for you, and I'll see you in the third video. Thank you. I hope it works.